Hello friends, welcome to the channel. In this video we are going to practice more with Cisco Packet Tracer tool for subnetting environment, means how we can construct and divide the network into multiple subnets and how the communication can be possible within those subnets. But before this, you must know how to construct and implement simple networks like star topology and some extended networks like extended star topology that we have already practiced in the previous videos, and link is also given in the description box. So let's start with this lecture with a brief introduction of subnetting and other related concepts, and later on we will have the practical demonstration of this subnetting environment, and we will also simulate this by sending a message from the source in one network to the other network, destination in other network. So this is first subnet and this is another subnet of the network, and both subnets are connected through the router. We will simulate this environment in detail. So let's start the lecture with a simple concept of subnetting. Subnetting is a simple way of dividing the traffic of a network and categorizing the network of an organization or institute or any firm or universities so that the traffic can be divided and a fast and a efficient computer network can be implemented or possible. Okay, so we have to make different categories of host, means we are dividing the host into multiple smaller networks and we call them subnets, right? Next we have IP addresses. So IP addressing is simple a 32-bit identification that of every host connected in the network that uniquely and universally define the connection of that device. And the IP address is divided into two parts. We can say that first is identifying the network ID where the host belongs, and the second part is defining the ID of the host. So firstly we have to find out network and then we have to locate the particular host. And IP addressing is possible in two ways. First one is classful addressing and the second one is classless addressing. So let's see how these two categories of IP addressing are different, means what we should use. We should classful addressing or classless addressing, and what type of addressing is useful for subnetting. So first we have classful addressing, where the network addresses are obviously divided into classes, and for classless addressing we are not having any class. So here, depending on the number of bits in network ID, we are categorizing we are dividing the IP addresses into multiple classes. If the first octet only belongs to the or only defining the network ID, then we are calling it the class A IP address. In decimal notation it can be identified with the 0 bit at MSB of the last octet, and in decimal notation we can check the range. If the range is between 0 to 127, that means address belongs to class A. Similarly we have class B, but this time we are having 2 octets and last 2 bits are 10. For class B addressing, in decimal range is 128 to 191. For class C addressing, we are extending the network ID by 1 octet, and this time we are using 3 octets for the octet, means 8 bits. Okay, so this time we are using 3 octets for the network ID and only 8 bits for the host ID. And the limitation of these classful addresses are that we are having limited number of networks and hosts. Suppose we are having a class C network ID as 192.168.100. Here we have some host ID. So if we are having this network ID, then we can have 2⁻⁷ combination for the host ID here. right? starting from 0 to here we can have 254, because we cannot have 1 to 254. We cannot use 1 to 254 because two host IDs means we cannot have the IP address as 192.168.100.0, because this is defining if we are having host bits, all host bits are 0, that means we are defining network ID. This is identifying network, no, not any host. Means this ID with all host bit as 0 cannot be assigned to any host. So here all host bits cannot be 0. Similarly, all host bit cannot be 1. All host bit cannot be 1, because if all host bit are 1, here if we have all 1, then all these ones are representing the broadcast address. That means we are using this address to broadcast any message or any packet to all the connected nodes in the network. So here another host ID that is restricted for use is this 255. This is for broadcast. Okay, we cannot use these two IDs as host ID with all host bit 0, with all host bit as 1. So here we are left with 1 to 254, means total 254 host for this class C network, 1 to 254, right? Similarly, we have class D and class E also for the classful addressing category, where first 4 bits are 0, and this class is used for multicasting, and for class E last 4 bits are 1, and this class is reserved. In decimal range, we can identify the class C with 224 to 239 range and class E by 240 to 255 range. Now, another important concept in the networking is Subnet mask. Okay, and this mask is used to identify the length of the network ID. As for class A, the length is 8 bits. Similarly, here we have length of network ID as 16 bits. For class C, length of network ID is 24 bits. So Subnet Mask define the length of network ID that is used along with the IP address to define the length of the network bits, means how many bits are used to represent the network ID. And for Subnet Mask, all the bits will be 1. Those bits are representing network ID in corresponding IP address. For example, if we have the address, once these concepts are clear, you can easily create subnet and can understand the concept of subnetting. So here if we have the address like 192.168 for class C addressing .100.0, or 0 cannot be the host. So if we have 1, then as these three octets are used to define the network, then in binary all for subnet mask, for this mask, all these bits will be 1. So here in decimal notation, subnet mask will be 255.255.255.0, means first 3 octets are used or defining the network ID in this address. So these subnet masks are used along with the IP address in this subnetting to define the networks. So here is we have the subnet mask corresponding to each class. For class A, subnet mask is this 255.0.0.0, because we have only one octet as network ID. For class B, we have 255.255.0.0, and for class C we have 3 octets as 1, 255.255.255.0, and these subnet masks are not applicable to these two classes. Next we come to classless addressing. Now after classful addressing, there are some limitation with classless addressing. That's why classful addressings are not in much use. So every organization need to divide a network into subnets, and for that they need to go with the classless addressing concepts, where just because with the shortage of class A and class B addresses, as the internet is growing day by day, and if you are having a class C address, as we have taken the example, if you are having class C address, you can have only 2 raised to power 8 minus 2, that is 254 number of hosts possible, right? But even with the classless addressing, we need to specify some length or subnet mask or anything that can specify the length of network ID. Okay, because without identifying the network, we cannot communicate within that network. So for any type of addressing, whether it is classful or classless addressing, we need to identify the length of network ID in an IP address. So here we will be using another method, that is /n. Here the /n along with the IP address, here x is representing first octet of the IP address, x.y.z.t /n. So here /n will be representing the number of bits used for the network ID, means number of bits defining the network of the IP address, right? So here /n define the mask. Obviously it is defining the mask, subnet mask, because for subnet mask first n bits are going to be 1 to define the network address, and remaining 32 minus n bits will be defining the host address. So for example, if we have n bits as a network address, then number of hosts in the network or subnet will be 32 minus n. This is the number of hosts, possible hosts. So we have to use the same formula. Number of hosts will be 2 raised to power 32 minus n, means number of bits used to identify the host, and minus 2, one for network ID and another for the broadcast address. So rules are same, just we need to separate. We are not categorizing into classes, IP addresses into classes. So we have to find some method to define the length of network ID, and that is our /n. Okay, so here is an example of class C addressing. We will be working with class C address only for creating subnets in a network also. So we will be taking the example of class C only. So here in class C, if we are using classful addressing, then the subnet mask will be this. For example, the IP address is this. Okay, 192.168.100.1. If the IP address is this, subnet mask would be this, and number of bits used in network ID are 4, number of bits used in host ID are 8. Similarly, if we are representing the same address with classless addressing, and we are having the same IP address, even then if you are having 24 network bits only, then everything will be same, means number of hosts, number of networks, everything will be same. Just we need to write it like this. Notation will be changed. 255 subnet mask will be 255.255.255.0, and /24 is indicating the number of network bits for this IP address, means first 3 octets are representing the network ID, first 3 octets. Okay, so here number of hosts we have already covered. Here if we are having 24 bits for network ID, obviously we are going to have only one network and no subnet, because we are not using any extra bits. So for classless addressing, after network ID, to define subnets, we need to borrow some bits from the host ID. And network ID will be same. For example, for class C addressing, we are using first 3 octets, right? So first 3 octets are used to define the network. And if you are dividing this C class network, because if we brought this address, even then we are not able to create multiple network. There will be one network only, and others will be host only. But if my requirement is to have multiple categories of network, then I need to use some bits from the host ID to define the subnet of the network. Okay, so for that purpose we will be borrowing bits from the host ID to represent subnet. And here, if you are using no bits from the host ID, then number of subnets will be 0, means we are going to have only one network with this IP address if you are not taking any extra bits from the host ID to represent subnet. Okay, so you have to work with host ID, means you need to borrow some bits from host ID to define the network of subnet ID of subnets. So let's take example where we are going to use this class C address, and then we will be borrowing the bits from host ID to use as a subnet ID. So here, for example, we have this same, means we are not having any bit from host to use as a network ID. Then we will be having 0 number of bits taken from the host ID. So number of subnets will be, as node bits is taken from the host ID, so we will be having number of networks at 2 raised to power 0 equals to 1, means we are going to have only one network. As we discussed with earlier slide, number of hosts will be 2 raised to 8 bits to represent number of hosts is 8, and we will be having 2 raised to power 8 minus 2 hosts, that is 254 hosts. Coming to the next, if we are borrowing one bit from the host ID, so if we borrow this one bit to represent the network ID, then in that case you can have 2 raised to power 1 equals to 2 networks. Okay, and remaining 7 bits will be representing the host ID. So you will be having number of hosts as 7, bits to represent host ID is 7, and number of hosts are 2 raised to power 7 minus 2, 128 minus 2, that is 126. Okay, but this time we need to write /25. Why we are writing /25? I hope you can easily guess. As we are having 24 bits from these 3 octets for network ID, now we are also using this host ID. So this host bit is also counted in subnet mask, and if you convert this binary notation, then you will get 255 for this octet, 255, and this will be 128. Okay, so this is our subnet mask for this network, and /25 is identifying the length of or number of network bits. Okay, so carry on. This is the case when we were taking one bit from host ID as network ID. If we are taking 2 bits, then we can have 4 subnets. 2 raised to power 2 equals to 4 total possible subnets can be created, and we are borrowing 2 bits from the host ID. Then subnet mask will be this 128 plus 64, that is 192. So this is the subnet mask, means this binary will be 192 in decimal, and this time we will be writing /26 because network bits are 26 now, 24 from these 3 octet and 2 from the host ID. So total we have 26 bits to represent the network, and the remaining 6 zeros here are in subnet mask we are writing it zeros, but these 6 bits will be used for the host ID, and number of bits to represent host are 6 here. Possible number of hosts are 2 raised to power 6 minus 2, 64 minus 2. Okay, that is 62. Similarly, if we are using 3 bits, I hope you can easily find out the subnet mask. We will be having this as subnet mask because 3 ones are here, 2 raised to power 6, 2 raised to power 5, 2 raised to power 6, 2 raised to power 7. You have to add all these numbers and you will get this 224. And this time network bits are 27. Total network bits are 24 plus 3, 27. Okay, and number of possible hosts are 30. Number of bits for host ID are number of hosts are 30 and number of bits is 5. Next we have, if we can have 4 bits from the host ID, okay, then we can have 28 network bits. Subnet mask will be this 240 for last octet, and total number of hosts are 14. If we have 5 bits from the host ID, then total number of subnets possible are 6. We can create 6 subnets, and number of host bits are 3. Okay, so total network ID bits this time will be 29, 24 plus 5. Now last category, we cannot borrow more than 6 bits from the 8 octets, from 8 bits. Okay, so here if we are using 6 bits, then we are left with only 2 bits for the host ID. So we can have only 2 raised to power 2 minus 2, that is 2. 4 minus 2 is 2. So we can have only 2 subnets for this category if we are using 6 bits for network ID, and the subnet mask will be 252 for the last octet, and total network bits are 24 plus 6, 30. Right? So this was all about introduction to subnetting an IP address, classful and classless. Next we will be taking an example that we will be implementing with the Cisco packet tracer tool. So you have to listen carefully and try to understand it carefully so that you can easily implement it with the Cisco packet tracer tool. So for this we are taking the class C address example where we are taking only 1 bit from the host ID. Okay, so with this case total number of bits to represent network ID will be 25, and total number of subnet, and we have already covered this thing, 2. Number of host 126, 128 minus 2, 126. Next, subnet mask for both possible subnets, means 2 subnets are possible within this IP address. We can create 2 subnets if we are borrowing 1 bit from the host ID. So we are able to create 2 subnets, and for each subnet mask will be same, because network ID bits will be 25 only for both subnets. Okay, so subnet mask will be same for both subnet, that is 225.225.128. Next we have, what can be the possible networks? Now we have to find out the network starting address or network or subnet address. So if 2 conditions are possible, if you are using the last bit of host ID, yes, you are using 1 bit, so that possibly be only can be the last bit of your host ID, host octet. So here if this bit is 0, or second possible case is if this bit is 1, so we can have only 2 networks, 2 subnets. Okay, so if this bit is 1 or if this bit is 0, 2 networks are possible. Similarly, to represent network ID, all other host bit must be 0. So we now need to find out the subnet IDs for two subnets. So this is our first subnet, this is our second subnet. We need to find out the subnet ID. So first case is if we have this host bit 0, means this host bit is now network bit. So for one bit, two cases are possible, either 0 or 1. So here if it is 0 or if it is 1, one case, then the network IDs after using this as 0 and this as 1, the network ID would be this is 0 for first subnet and this is 128. So these are two subnet IDs under this address, under this class C category, when we are using one bit from the host ID as network. So total 25 bits are representing the network ID, and these are two possible subnet IDs under this category. Okay, I hope this is clear and we will be implementing this thing. Next, let's find out the first and last address within a network. Suppose you are creating a network, two subnets we are creating, one subnet and this is another subnet. Here we have last starting network ID at .0 and here we have host ID as .128, right? I'm not writing this all, so I'm just have written the last octet of the subnet IDs. So .0 and .128. These are your subnet. This is first subnet, this is your second subnet, and each subnet is having 126 host. Okay, so as we have already covered, we cannot use network ID, as a host ID in the network. So all total 126 hosts are going to be distinct ID, and you can only provide consecutive addresses to the connected host in a subnet. So this is the rule. Number of hosts always in power of 2 will always be in power of 2. Secondly, you need to provide consecutive addresses to all the connected nodes in the network. This is the rule. Okay, so here the first address after this is going to be 1. Let's write it complete. 192.168.100. So first address is going to be 1. Similarly, what can be the last address? What will be the last address? As we are having 126 hosts, so the last address will be 126. Okay, and for this network, let's see this. So this is our first address of the network and this is our last address of the network. And if we have all bits as 1, what can be the broadcast address of this network? Okay, so we need to find out the broadcast address of this network. For this, for last octet, if we have first bit as 0, all other bits, means all other 7 bits will be 1, and this will form 127. Okay, so after the last host, next, if all host IDs are 1, this is network ID, this bit is network bit. Okay, not the host bit. And if all the host bits are 1, that will be your broadcast address of the network. So here the broadcast address will be .127. Okay, similarly for this network we are going to have first address as 129. Okay, and the last address will be 254. 129 plus 125, as we have total 126 host. So 129 plus 126. Next, the broadcast address will be 255. Okay, so here we are done. The first address is 129 and the last address is .254 and the broadcast address is 255. Now you are ready to start the simulation with these two subnets. We are going to create these two subnets with 2 hosts per subnet. Okay, not more than that. Just to avoid the confusion, you can create up to 126. you can deploy up to 126 hosts, but we will be taking only 2 hosts per subnet, and 2 subnets are possible for this IP address. Okay, so let's start the practical implementation of this. So this we will be implementing with Cisco Packet Tracer tool in a minute, where we are categorizing the network into 2 subnets that we have already covered. This is our first subnet, subnet 1, and this is our second subnet. This is our subnet 2. Now, to make the communication possible within these networks from this node to any other node in other network, one thing that we need to categorize is all the hosts must be assigned the sequential IP addresses in a subnet. Okay, so as I have provided the .1 to first PC, first host, .2 to second host. Similarly, in this network, as starting address is network ID is 128. This is network address, right? So first address is 129. This is the first host with address 129, and this is second host with address 130. So all these addresses should be in sequence only. Next, we need to configure the router. We will see it's in practical also. So we need to configure the router also. Now router cannot send anything to the network. Means router is not going to identify this subnet or to this subnet. This ID is only applicable within this range, and this network ID is only known within this range. Okay, so to create the subnet, we need to assign one IP address for this network to the router. Okay, and that IP address is known as gateway. That IP address is known as gateway. This gateway play a major role in networking. Gateway is a kind of intermediator to transmit data from one network to another network, and it perform the conversion of data for multiple protocols. So here we are not going into much detail, but yes, we need to configure the router with gateway for this network and gateway for this network. Okay, here what IP address will be assigned to the gateway? As we have the rule to assign IP addresses in sequence only, consecutive IP addresses to connected host in a subnet. So for first subnet, as we have assigned .1 and .2, 2 addresses are already occupied, are assigned to 2 hosts. Next, the third .3 will be assigned to the gateway. Very simple. And for the second subnet, where the starting address is 129, the second host is at 1.130, then the gateway will be .131. Okay, so router is not going to send the packet at this network ID. Router will send the packet to the gateway. So gateway is we can say that intermediator for this data transmission, for any data transmission within networks. So router will be configured with this gateway for this subnet. Same way, router will be configured at one port with this gateway address for this subnet, this second subnet, and this is the gateway for first subnet. Okay, we will see how to assign these gateways to routers. Next, another thing you need to define is the subnet mask, because router need to identify the network ID, and how a router will come to know about the network, how many bits are used for the network ID by the mask. Okay, so to define the network ID to the router, we need to define the subnet mask also. So router will also need the subnet mask to identify the network bits from the gateway address. So we need to define the gateway address and the subnet mask. Subnet mask will be same for both the subnets. Okay, so this is the This is the configuration part, and now we will see how the data communication is possible and how routers are categorized, how the routers are configured for such setup. So let's start the demonstration. For practical purpose, I have already created the project for this subnetting with the same class C IP addresses and 2 subnets. And here is the same network with 2 subnets, with one subnet with ID .0 and another subnet with ID .128 that we have just discussed. Initially, all the switch are taking time to configure, means to boot up. So let's just check the configuration of these devices, as this PC is assigned with this IP address .1 and this PC is assigned with IP address .2 as host ID and the subnet mask as well. So here let's check the subnet mask. So here, as we are using classless addressing, and this is the IP address, and here we are using first host bit as network ID. So you need to define the subnet mask by yourself. Okay, and third thing that you need to define is the gateway. So as we discussed, as we have two systems or two nodes connected in this network, so we will be using the third ID, means the next ID after the total number of hosts in the network will be used as a gateway. So here the gateway for this is .3. Okay, as we have discussed in the slides. So .3 will be used as the gateway here. Same way for another PC in the same network, we are having same network ID, same subnet mask and same gateway. All the system in one network will have same subnet mask and same gateway. And here the IP address is this with same network ID, but the host ID is 2 here. Host ID is 2. Similarly, these systems are configured here for both systems. The gateway will be, subnet mask will be same. The gateway will be the last address of the network. So here next to last address of the network. So as we have the host with host ID as 129 and next is 130, so gateway will be 131. As you can see, I have provided the gateway as .131, subnet mask as same as the first subnet, and here the first address is .129 for this system. And similarly, we have assigned the same subnet mask, same default gateway for this host, but the host address is .130. Okay, now let's see how to configure this router. So for this router, we have to select the configuration option. Next, we need to turn on the router, means we have to turn on the router for this switch of subnet 1 and this switch of subnet 2. So for that, you need to open the configuration of the router, and then from this you need to select these fast Ethernet connections, not serial. For these we are subnetting, we are using fast Ethernet connections. So here at 00 port, we are connecting the first network. See, the first network we are connecting at this host, at this fast Ethernet 0/0 connection. So here we are adding the address of gateway. So as a gateway was .3, so we have added the gateway here as 192.168.100.3 and the subnet mask of the network, that will be same for all for both subnets. Next, you have to check this option, means you need to turn the router on for this Ethernet connection. See, if you are turning it off, these dots are turned to red, means data connection is not possible. So you need to turn these connections on. Similarly, for second subnet, we have to set this fast Ethernet 1/0, and again you need to turn it on for the data connection. The gateway for this is after the last host we have 1.131 as a gateway that we have already provided and the subnet mask. So the router configuration is done, but it is taking some time as we just kept on keeping it on or off, so it is taking some time for booting process. As this red dot turn green, data connection will be active and we are able to send the connection or send the data from any host in from one network to another network and vice versa. So all the connections are green now. Let's try sending a simple data packet unit from one host in this network to another host in this network. So we are picking this as the source and this as the destination. Okay, so one system from this source and this is the another system from another subnet as the host. Okay, so you may get the this type of communication take time, so you may get sometimes the connection taking time to set up. So at first time you may get the timeout error or failed. Okay, so you need to wait. So let's try again. This will be the source and this is destination. This time we got the status as successful. Okay, so the status is successful. Now let's demonstrate it with the simulation. For that you may get, for the first time you may get timeout or failure, but you can try it again or it will take some time to convert the failure or in process communication or timeout error to the successful status. So now starting the simulation, you can also press Shift S. So after this, from this system the packet is transmitted to the connected switch. Now the switch is sending the packet to the router. Now router through gateway identifying another network, another subnet, and now this switch will send the packet to the destination host. Now the acknowledgement will be sent by the destination host, received by the switch, and now router will send the acknowledgement to another subnet identified by the gateway dot 3. Okay, so here the acknowledgement is received successfully. We got a tick here. Okay, so here in this video we have created these colored boxes just to differentiate different subnets. If you are new to this, you can get this option of drawing these boxes or and labeling them from the tools menu bar. So you can easily get the option from tools menu bar. You can also check whether these two systems are data communication acceptable or not by using the ping command. For example, here I will be using the ping command from the first PC of first subnet. This is the first PC of first subnet to first system of another subnet, that is 192.168.100.129. Let's see. So the ping is successful. That means the connections are okay. There is no problem with the connection. So you can check in either way by using ping command or by using by sending a packet data unit, and you will get the successful status. You may not get at this for the first time, but yes, after 1 minute, 2 minutes, you will get the status as successful. Thank you. Hope you learned something from this video. So bye.